I'm Alison Flatau. I'm a professor of Aerospace Engineering at the University of Maryland. I also serve in the role of being the Associate Dean for Research part-time for the Clark School of Engineering. My research is largely focused on two broad areas. The first one has to do with magnetostrictive materials and their use in sensing applications, some use in actuators. And then the other area, sort of a mix of other sensors and other actuators using spark materials. Some of them deal with active flow control. I've had projects that dealt with wearable sensors and just generally things that might have to do with sensing technologies. One of the areas I've gotten into just in the last 10 years maybe is looking to nature to come up with ideas for sensors that we're not currently using and matching that to the capabilities of the materials I study. Magnetostrictive materials are materials that change their shape, or they have striction in response to magnetic fields. And conversely, if you strain them or constrict them, their magnetic state changes. And so you can use them to sense stress by tracking the change in magnetic induction in the material, or you can use them to produce displacements or velocities or force by applying a magnetic field. This magnetostrictive material that I'm using right now is an iron alloy with gallium. And because it's made out of iron, it's very robust. It's largely iron. It's something you can bend and deform. So we've been, and it's malleable, so we can make it thin and different wire-like configurations. And there's a lot of opportunities to look to nature where animals have whiskers. It's really fascinating to start studying the animals to understand where the sensors are on their body. They're usually in arrays. You don't just see one whisker on an animal. I've got one collaboration right now with folks at Montana State University where they study cricket hairs. And they're trying to understand the evolutionary processes that went into the crickets that we know today, why crickets have two cerci and why those cerci have something like 700 hairs that are sticking out at different directions. Why are the two cerci pointing out in this direction? How do they use those in defense against prey that are coming? You know, they can detect animals that are flying down thinking of eating them for a snack. So we're interested in collaborating with them to get ideas about how to design our sensor arrays for optimal sensitivity and weight to performance ratios. You know, because mathematically it gets very, very complicated. You have 700 hairs sticking out at different directions and two whiskers that are pointing into cerci that pointing at different directions. So we're collaborating with them, so we learn about sensor array design. They're collaborating with us because they can go into the animals and trim existing whiskers, for instance, or existing hairs to try and understand how that alters their sensitivity. But they can't add whiskers. They can't make more dense arrays. Whereas once we match our mechanical model to their biological model, we can start doing things that the animals can't do to understand why what may not be an engineered optimal is still what exists in nature. Most of engineering is going to be bio-inspired as opposed to biomimicry because the mission of the biological systems are very different than the mission of the engineering system. So you wouldn't want to mimic something as much as draw inspiration from something. All these biologists are having fun talking with us engineers because we create opportunities for them to study their systems, and at the same time, there's so much for us to learn that when I came through the system, I didn't really take a lot of biology courses, so there's a language of biology that I'm not skilled in. And by collaborating with these folks, my students are learning to speak that language. And I think it's just opening all kinds of opportunities for creative thought that just by staying strictly in the core aero discipline, we just haven't been exposed to.